So moving on now, we're going to talk about 3D visualization. We have two presenters from Arcadis. Josh Gravenmier is he's North American Oil and Gas Program Lead for the Arcadis Incident Response and Recovery Services Team, which responds to over 100 incidents annually. And Eric Rogoff is the Operations Data Visualization Lead for the Information Management and Data Visualization Group. So with that, I will turn it over to you two. Thank you.
Great, thanks. Hopefully you can hear me.
Yes.
Yes.
Excellent. Well, yeah, thanks for the opportunity to speak with you today and be part of the technology workshop. There's lots of good topics over the week, and we hope you like ours as well. So yeah, I'm Josh Gravenmier, and along with my cohort, Eric Rogoff, will be talking about utilizing the potential of all of the incident information through 3D visualization to maximize response efficiency. And Eric, you can go ahead. So we're here because lost inventory happens. Like the figure that Tom Cullen presented before lunch, that there were 1,354 reported spills of oil in California in 2020 alone, which works out to be, on a quick calculation, 3.7 spills a day. Obviously, there's a need, and this visual here is from the state of Washington, and it also shows that California is not alone, and it's from the period of 2015 to 2020, and just oil to water, and there's other too, and this works out to be about 1.4 spills per day. And what do all these incident needs, what do they need themselves? And that's data, right? And on the next slide, the stakeholders themselves expect fast, transparent data, open stuff, right? So the speed of social media now means that you need to provide data much faster in order to prevent misinformation from happening. And this is especially true for larger events. Next slide, please. So we've been talking about the advances to the toolbox today, but it wasn't so long ago that we were just using highlighters and hard copy printouts and whatnot, right? So now we can obtain near real-time data from a variety of sources. We can interject the trajectory modeling that Peter McCarthy just mentioned, etc. And really that tool would have been pretty helpful, because we were one of the ones responding during the Yellowstone River response, and the river flows were very high, and it was really a challenge to get ahead of the downstream edge. So all these new tools are going to be great going ahead in the future, right? So there's that, and so much more data that's now really available, and data management and compilation of that data into digestible outputs is a real key component of a response now, because the decision makers are typically in a room somewhere, or now with COVID, they're doing Zoom calls, and that's really someplace else. Eric? So any maps that we create, they need to be clear, they need to be concise, they need to be accurate. And that's going to be helpful for creating the information we need for the decision makers to make the most appropriate decisions that will focus the limited resources that we have to do the maximum good and do it quickly, right? The widespread use of unmanned aerial vehicles are a great tool to provide rapid operational awareness with site photos, but they're being used more and more to create 3D images as well. And the next slide will show you how we have a surface orthomosaic model that can be generated from stitch imagery. This is a train derailment. And you have a standard photo on the left, but we can also do a variety of manipulations depending upon the camera on the UAV itself. And the photo on the right, you can see, is a generated digital surface model that is a 3D representation, and also can do topography, which can be really useful in evaluating response activities that may be limited due to steep slopes and other site characteristics. Next slide, please. standard maps are shown here of an excavation. They're really good, right? Gives you lots of good information. It's useful information. The figure on the right highlights an excavation around a pipeline that had a containment issue, right? The photo itself provides additional context, but by adding in the information from all of the other data sources that were collected around the incident, all these monitoring wells and what have you, and then compiling that into a 3D format, it allows you to generate a much clearer picture of the area of impact and get a better understanding not only of the impacted zone, but also of the areas that aren't impacted. And so this depiction right now is a 3D PDF, and it's an emailable thing. It doesn't require any um, special software, and you can take a look at a variety of angles on it. With this depiction, you can better refine, where to stop excavation or isolate different soil concentrations, which allows for a much more focused remediation effort, while also being able to better quantify volume calculations and disposal streams, as those have a really big price difference on them, right? So this kind of information really helps the incident command, the regulators, and even the public better have a better idea of what's going on, and it allows for data transparency related to the response activities. So, I'm the person that utilizes the information, but Eric is the one that's really generating it, and I'll have him describe what goes into that.
Okay, thanks, Josh. Can everybody hear me?
Yes.
Yep, okay, great. So the program that we use to synthesize all this information is called the Earth Volumetric Studio by CTech. And as Josh was just discussing, showing in that 3D PDF, this was a pipeline release that we integrated the information in that to be able to communicate with regulators and our responders out at the site and start doing planning for excavation. So I'm going to go on just a little bit. What we typically do when we have these spill responses, you have a tremendous amount of data coming in a very short time. You've got your digital elevation models, surveys, you can get LiDAR flyovers. We start getting a lot of analytical data. Any USGS topos we can get of the area or geologic maps. We start integrating boring log information that we're getting from drilling. Any information on local utilities, sewers, pipelines. We use a lot of high resolution investigative tools to get subsurface information so we can see where, if it's a pipeline release, how far the fuels have spread in the soil and groundwater. If we have to do geophysical surveys or integrate with other GIS information. So you just start getting this flood of great information in a short period of time, but the challenge is putting it all together in a way that everybody can use. So the Earth Volumetric Studio, some of you may be familiar in the past. It used to be called the Environmental Visualization System, then the Mining Visualization System. And due to a lot of improvements over the last few years, it's tremendously more cost effective due to Python scripting and other software improvements. So we can do these things a lot faster and at a fraction of the cost that we used to be able to do. Some of your viewing options, you'll see in a little bit, something called the Fordham Player, which is a free download and fully interactive. The 3D PDFs, which you just saw an example. We can do videos. We have a lot of web-based options now for showing things. Power BI is a digital dashboard that we can put together things in, and we're starting to do things in augmented reality as well. So just looking at this, getting back to this example, once you get all your information and you can get a really high level volumetric analysis, notice also we've got a 95% confidence interval here. So you can do your sensitivity analyses, see if you need to gather more data, see if you've got enough to make the regulators happy in your investigation so far. And you can start looking at not only your volumes of impacted soil, but you can also do calculations to get a rough idea of what your volume is that's been released to the subsurface. So these next few slides just kind of go through and show you, once you have this set up, you can get different sub areas, go through very quickly, start getting the volumes in each of those polygons. And ultimately, the take home of all this is that you're able to get to all these different volumes, do it for your excavation planning and staging of trucks. So we can basically go from what used to be a very long exercise down to, once we have all this information, we did that all in about a day. So let me just show you really quickly the Fordham. Hopefully everybody can see this. This is what was used to generate those stills, but if you notice, I can rotate around. I can zoom in very easily just by rolling the mouse wheel, sliding back and forth. With your right mouse button, you can pan. And notice here at the current state up at the top, you can click through and see different permutations, sort of like equivalent to a PowerPoint slide. So it's a great way to be able to convey information, and teams can look into this in as much detail as they want. Very easy to share with your technical teams and regulators. So moving on to another case study. This one is a pipeline release where we flew a drone and also did a lot of borings with something called an ultraviolet optical screening tool. So from our drone, we were able to use photogrammetry. There's close to 1 million vertices here to get our topographic contours, this is sort of a remote area. So lots of times your topographic information that you can get from DEMs is just really not sufficient to be able to do your good excavation calculations or know what's there. So the drones really come in handy. Here's the next step, just shows the topography developed from that. Going a little bit into some of the high resolution characterization and geophysical data, this project used an ultraviolet optical screening tool, which gives you a tremendous amount of data. It's 20 to 30 rows of data per foot. We'll also be able to do things with adding in with boring logs or surface geophysical surveys or downhole surveys as well. So I'll show you the Fordham in a minute. All of this UVOS data, there was a tremendous amount of information. The release happened right around here, but filled this irrigation trench and spread out the fuel over a very large area. But since it was in the bottom of the trench, the fuel penetrated a little bit more deeply, and there was a lot of unimpacted fuel closer to the surface. So we drilled 285 UVOS borings to 25 feet deep. So it's a tremendous amount of data, over 71,200 points in this exercise. So just clicking through a few stills, that's taking away the aerial. What we used that information for was to kind of develop the bottom of the area that was impacted with free product, and then also be able to generate the top of that surface as well. So we could come up with a volume that was impacted with product, and then also be able to calculate, what was that volume of product above that, which we would have to remove, but that wouldn't be contaminated or need to be dealt with any kind of special disposal. So I'm just going to bring up that Fordham. Notice here you can zoom and go into tremendous detail. The drones are really terrific as far as how much information they can give you, and great high resolution photographs and topography at the same time. So this just walks through some of those other states, but this is the truly interactive portion of it, which is really nice. You can get your isolines there. You can get in all of these data posts. You can fly into an individual boring of interest and see what those results were, what those very high impact areas are. And this is just kind of how we use that to define the bottom of the excavation and then the upper surface. This is showing that volumetric calculation. And again, just an interactive view of what was unimpacted that we could dispose of, just kind of get it out of the way and then deal with the more impacted soil beneath. So that pretty much wraps up our presentation. So if anybody has any questions, I think the primary contact, if you need to get a hold of us, is Josh. He's our head of the IRR group for Arcadis. So if anybody needs to get a hold of me, my contact information is there as well.
Okay, well, thank you, Josh and Eric.